Good morning, everyone. Today we are going to be adding cryptography to our game. One of the things I noticed, right, is this game design makes it inherently very difficult. Very difficult, right? To, how do I say it? To like, if let's say, if let's say, we're doing like competitive gaming, right? If we're doing some competitive rock paper scissoring, right, or whatever, right? It's kind of impossible to make sure that both parties are following the law, right? And ideally that shouldn't matter much, right? But the thing is, if we're gonna be doing that, right? It's kind of impossible normally to play a game of rock paper scissors, for example, right? And I think that's very important for us to figure out. And I think I might have the solution, but it requires me to look through some things that I haven't really gotten too much experience with. Hey, dude guy, welcome to stream. Welcome to stream. How are you doing today? What is that emote? Is that a chicken? Huh? Oh no. Okay, that's Shaq. Or is that? It's kind of hard to see. It's kind of really hard to see. You know, like a detailed GIF like that, in like, it's LeBron, okay, because like I can barely make it out. I was 100% sure it was a chicken for a moment. You know, I'm so sorry. um, have you been here yet? Have you been to one of our programming streams yet, dude guy? Have you been here to one of our programming streams yet? Because we're designing a video game right now, you know? Oh, okay. Nice. Yeah, so you'll kind of know what we're on right now. I've improved a lot of systems in the time we've last done this. Yeah, we have like a feed system and all that kind of stuff yet. Feed doesn't currently work in 3D, mind you, only in 2D. But we have like a mini game system going on, right? And then now we're gonna be making sure this shouldn't crash it and should just default to the beginning world, so that's fine. Right. There we go. Else UI dot show system debug. Okay, here we go. I think I'm gonna make this an error, because errors don't show up when we go into the screen, alright? So there are some. Oh wait, debug. There we go. So these debug messages, they show up here only if you've checked it off on the toggle debug text thing, see? So now we go over here, yeah. Hey Nexus, we're currently adding cryptography to our game. Alright? Because the reason why we need that, right, is let me let me pull up paint real quick, right? Let me pull up paint real quick, alright? Okay, so let's say we have a game of rock, paper, and scissors, right? I have no art skills. I don't know why I started doing this. But let's say we're playing rock, paper, scissors, right? Currently, if I want to play a round of rock, paper, scissors with you, it's really easy to cheat, right? Because, both people can't send messages at the same time, since these are going at like millisecond paces, right? If I add like a wait or something, alright, then it's gonna be like crazy easy to cheat. Because here, right, if I'm putting up a wager, right, like let's say I'm putting like 20 currency, right? Both of us are betting like $20, right? and I decide, hey, I'm gonna be playing rock, right? And I send that to you, right? I send this to you, right? Then you can just wait for me to send you rock, right? And then as soon as you receive that, right? Then you're like, oh, I'm gonna be playing paper, and then you win, alright? So the thing I need to do here, right, is I need to add, like, cryptography and make it so that when I send a message, I can also make it a encrypted message, right? And then that encrypted message, you know, I can like send a follow-up like key with it, right? And that allows it to not be read by anyone else, and also only allows it to be read by the time the key arrives. Okay, here we go. So that's gonna actually be pretty rudimentary, I think, right? Because I just thought up a better way to code this, like, literally 5 seconds ago, right? So we're gonna be doing that today. And that's gonna be somewhat quick. I just need to make a new object for cryptography, right? And this is gonna be here mainly to just track like cryptography things, you know? Okay. So here, right? Let me open up the cryptography docs real quick. Note, cryptography is similar to like cryptocurrency, but not exactly the same thing, right? We are not making a cryptocurrency here, just for anyone who does not know what cryptography is. Cryptography is basically the act of code, right? Like making like a code or a cipher or something that can't be easily broken, right? The thing we're doing, right, is we're pretty much making a key, and then we're making like a cert, right? And then we're gonna encrypt some data, right? And then send that encrypted data over. And then once the person gets the key, then they can unencrypt the data, right? But they can only unencrypt it once we, you know, send over the encrypted, you know, I guess. So that's kind of what's happening here. That's kind of what's happening here. Okay. Okay, so first we need to track all of our so we need to track all the encrypted messages, right? This does leave a section of space, right, for an encrypted message to linger in memory, right? So one big worry we have here, right, is, you know, if they send enough messages, right, what's stopping them from, you know, blowing up our memory storage? But at the same time, I think we're gonna give them a little bit of buffer room and just be like, nah, we're not worrying about that. Because if someone decides to spam your storage, right, I don't really know what to do there, because like as soon as the program crashes or you exit out of the program, it should be fine. And in theory, Steam should be watching out for that as well already, right? So there's not much we can do here. The messages are being stored in storage anyways. It's just like only messages are, you know? Yeah. Here we go. Of our encrypted messages, this is gonna be a dictionary, right? And I'm gonna just make a empty dictionary for that. Alright? Okay, nice. So this is gonna store all the encrypted messages from this current session. And only from this current session, right? Then, right? Then what we have to do, right, is func save message, right? And this message is gonna need a number, right? What is it called? No. Message ID, right? Actually, it's gonna have to be a dictionary of dictionaries. I love my dictionaries of dictionaries, you know? I absolutely love my dictionaries of dictionaries. Message ID, it's gonna need the user, what did I call that again? I don't remember why I call it in the Steam peer-to-peer. Identity. Okay. Sender identity. That's to prevent you know, people sending like the same message ID, because they're not gonna know what message ID other people have sent, right? Expected semicolon after function declaration. And then after that, we're gonna need a I think a byte array, actually, right? Because this encrypted data right here, right? CryptoKey.encrypt. This returns a packed byte array. Okay, that returns a packed byte array. That's kind of what we were expecting, anyways, right? Packed byte array. Okay, there we go. So now that's gonna store, right, encrypted messages, and inside of that, sender identity. Inside of that, message ID, right, equals payload, right? And it's just gonna store it there and not return anything, right? We don't need this one to return anything at all. Func decode. Func decode message. This one, ideally, we use the sender identity, right? The message ID. And then that's it. That's all we're inputting. And it should decode to something, alright? The problem here, though, right, is we can't decode it to an object. We can only decode it to a value, right? And if that message returns a bogus value, that's kind of not what we want. So I think here we're gonna just return it as a decoded packed byte array, right? Either that, or we could pipe that into the messages object. Because, okay. Let me run this by you guys, right? Let me run this by you guys, right? We have this function right here called read peer-to-peer messaging, right? And here, you know, we process the message, right? And we do all this kind of stuff, right? We could break this off into a separate function, right? And then, you know, and then we process, we process it, right? Because I don't think that should be bad, actually, right? I don't think that would be actually that bad. Because all we would have to do, right, is we would just return the payload with its new values, right? Right? But also, we do check the data up here as well, you know? Okay. I think we should be able to do that. Read peer-to-peer messages. Process message. Message. Okay. And then here, right? And there should be a dictionary, right? And then we do that. And we do that. And that should work the same exact way. Alright? That should work the exact same way right there. Yeah, no, that I think should work, right? And now what we can do, right? Now we need to make sure that when we send a message that is encoded, right? We attach a key to it, or not a key, but a ID to it, all right? And then we make sure. Oh, okay, no worries, Nexus, no worries. We are currently just working on adding cryptography to some of our messages right now. Because what I did is I broke out this thing to process message, right? And then, you know, yeah. Oh, how's that going? How's that going? Ah, fair enough, fair enough. Da, 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 da. Yeah, no worries, no worries. Have a good Risk of Rain session. I'll be kind of just ranting to myself as I figure my way through this, you know? Because I need to break down how I do two things right now. I need to figure out how I encode and decode things. And then I need to figure out how I undo this, you know? I need to figure out those two things. I need to figure out those two things right there. So I think that would be through here, right? Oh, I would also need a sent array, right? This would be the received. And this would be... There we go. So this data is always a string. That's a chat message. That's a chat message. Send chat message, send lobby data, send kick, send ban. Send message to user. Ah, okay. So that all uses are send message to user code right here. And that automatically turns it into a packed byte array, right? We can just hijack this function right here, I think. Okay, so now we're adding this thing right here, which is automatically there, encrypted, alright? Any prior functions are not gonna have encryption added into them, alright? But if they are, if that is true, right, or false or whatever, right, you know, it will be added on to that, right? Okay, this data dot append array var 2 bytes payload, right? So that's a byte array, right? So that's a byte array right here. What does var to bytes return? Var 2 bytes, go dot. Var to bytes right here, right? It returns a packed byte array, right? Meanwhile, encrypts returns any packed byte array into a, you know, encrypted thingamajig, right? That's interesting. That is interesting, because we're gonna have to do something a bit more complicated than just doing that, right? If encrypted, then we, you know, we need to make that a, what is it called? A global variable, cryptography, scripts, global autoload, networking, cryptography, right? Okay. Okay. So we need to make the cryptography class actually control, right? What we, how do I say this? We need to control what it actually encrypts inside of this context, right? Because we can't make it so that only, we can make it so that only some of it, but not all of it, can be unencrypted through the normal method, right? So I'm gonna grab this code, right? Encode. What is this called? Encode payload. Encode payload. Load. Okay. This is kind of complicated, right? Else. Boop. Boop. Okay, there we go. Okay, so we encode the payload, right? And that essentially does this right here, right? And then, you know, we do the Broly compression, right? There we go. That looks good. I think that looks good. It'll add a bit of overhead by just checking this variable, but I don't think it should be too high that we need to worry about that overhead for now. Just because this, we're not doing this too often. We're only doing this before we send it. So at most, each message is going like once a second, right? Or once a frame, so 60 times a second. Maybe more, right? And because of that, right? And because of that, we don't really need to worry too hard. We do not need to worry too hard. Here we go. Oh, also, I think each character should only send their locational position like once every 60 seconds instead of once per frame. Because I'm getting like 250 frames. People do not need to know my position every 250 frames, you know? That's excessive. That is excessive by any regard, right? So we're gonna be limiting that soon enough, right? Actually, we'll be limiting that now. We will be limiting that now before I forget. Characters. Oh. Okay, we're already doing that. We are already doing that. Nothing ever goes wrong. Ever. Nothing ever goes wrong ever. Here we go. So now we encode the payload, right? What we essentially have to do, right, is this right here, right? But we return a different byte array. Okay, critical thinking skills do not fail me here. So here we have the payload, right? Whatever we're doing, all right? So we pull up the tutorial, right? Okay. Okay, and we can just use a string for that as well, which is really, really nice. Because we can just load the key through a string, right? Okay. Okay, okay. Okay, okay, where are we going here? Okay, I'm gonna just make a crypto object at the start so I don't have to create a new crypto object each time. So this is our crypto object, right? Okay, there we go. Okay. So var key is equals to crypto dot generate RSA 4096. There we go. Okay, so we create a key, right, for the message that we're sending, alright? Okay. And then encrypted is equal to encrypted is equal to crypto.encrypt key, alright? And then the payload. Okay, so we save the messages received here, alright? Okay. So we got... Da, 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 da. Da, 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 da. Should I just return null here? I think I should just return null here, guys, right? var encrypted is equals to crypto.encrypt key payload, right? Okay, we definitely need to return encrypted then. There we go. So we're turning this thing into a... Oh wait, var to bytes. var to bytes. Right. So we're turning this into a byte, right? And that gives us encrypted, whatever encrypted is. And then we can kind of continue on with our day. So that returns that, right? And then, okay, so that's like our encrypted message right there, right? Can I put a byte array in a byte array? Encrypted. Okay, I need to look at the send for every single message prior, alright? Okay, so when I do send locational data, right? When I do send locational data, like for example these ones, this is a valid format right here. This is a valid format right here, right? Okay. So now the encrypted payload, right, is equals to type encrypted message, right? Payload, right? Is gonna be encrypted, right? And the message ID is equal to okay, here we go. Well, okay. This is fine. This is fine. We are not dying right now. Well, ID is equal to 0 or ID da 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 da. I died stage 2. Shame. How many stages are in Risk of Rain again? Wait, are you talking about Risk of Rain 1 or Risk of Rain 2? The new Risk of Rain? Which Risk of Rain are you talking about, Nexus? Which 2? Okay, makes sense. How is the new Risk of Rain? Because I remember people talking about there being a new Risk of Rain out there, right? But I haven't heard anything about it. Or, random int dot. There we go. Okay. So var ID is gonna be a random integer that is not 0 and not an encrypted message sent, right? So that means we've never used that key, that number before, right? Okay. And ideally, we're not gonna be using many of these in general, right? But once we decode the message, right? We also do want to remove it from this key here, right? So, you know, the only times when we would have memory bloat is if we're sending messages that never get decoded, right? So that should be fine. Okay, and then message ID is ID. All right. And then I turn this into another byte right here. This is so stupid. And then we return encrypted. So here we go. Okay, so that returns the payload, right? And then they'll be able to unencode that into a normal message. Oh, but we also have to already compress the thing, alright? We have to do another layer of compression, right? This data equals this data dot compressed. File access compression gzip, right? And then we return encrypted payload. So that does like 2 layers of compression on it, alright? No way. Wait a second. Wait a second. We have to already encode the payload, right? We already have to encode the payload. Wait a second. How does this work? I feel myself like overthinking right now. I can. Okay, one thing. I think it might also be the light that's above me, because I have a Logitech G Hub like light, right? Like this thing right here, right? And currently I have it way too cold. That's a bit too hot. Like that. And I can dim it a little bit. That's so much nicer. Too warm. Okay. Nice. Because I was worried about it, like, interfering with the tracking quality, because, like, if it's too warm, does it send out, like, infrared, you know, that kind of thing? But, okay. Okay, so... Okay, let's walk through the process right now, alright? Okay, let's walk through the process right now. So we get a pack byte array called this data. And this data is just var 2 bytes from payload. And then we compress it. Right, so when we're reading a message, right? Okay. Cryptography is confusing, guys. Cryptography is confusing. I'm gonna complain to the evil cats. Okay, yeah, there we go. Okay, because messages should be encoded by the Steam network by default, alright? But this adds like another layer of like, another layer of like encoding and everything, right? Which makes it like a decent amount more complicated for us. Okay, so when we're sending it, right? When we're sending the message, it should be if encrypted, right? Then we get a non-compressed array, right? We get a non-compressed array, which they're gonna compress again. Okay. Okay. So var to bytes, type, encrypted payload, encrypted. This should work. This should work, alright? But the problem is, this payload is currently not compressed. We need to compress it again, alright? We need to compress it again, alright? Before we do it again, you know? Okay. And how do we compress it? We use this data, compress. So we compress it once, right? And then we compress it again. And that should allow us to double uncompress it, alright? In theory. Because this byte array right here is one byte array. And then we have the other byte array as like a compressed byte array still. Wait. Huh. Wait a second. What's our read logic looking like? This should be fine, I think. So we compress the message once, right? And then we put it inside the thing, and then we compress it again. I sure hope this doesn't, like, uncompress it the entire way again, you know? Kinda deal. Because we're putting a compressed thing inside of a compressed thing. Okay. Encode payload, and... that should work, I think. That should work. If... and... wait, this should be received, okay. as long as we have those two layers, right? What we want to do, right? What we want to do, right, is grab the payload, right? That's this, right? That's whatever this is, right? And then we wanna unencrypt it. We wanna decode it, right? So that would be crypto dot decrypt this with this. And then the key is gonna be a gonna be a string. Okay. And there we go. Argument 1 should be crypto key, but is error. And then we do crypto key load. Okay. So now that we have the key, right? We've loaded the key and we've decrypted the message. That should return a that should be the key, and that should return the decrypted byte array. That should be a packed byte array. Okay. Equals. That's gonna be a dictionary equals that's gonna be packed byte array That's gonna be the result, right? That's gonna be the decrypted byte array, right? And then we're gonna be turning that. We're gonna be turning that. And that's gonna be returning a dictionary, right? And that dictionary should have all the stuff we normally have, right? So then now we have a dictionary of dictionaries, alright? Okay. Okay. Let me see this real quick. Okay. Okay. We have to kind of sit down and like think about this a little bit. Okay, so the first layer has identity, right? Identity, right? And then payload, which is bytes to var decrypted byte array. But that should be a byte array still, I believe. Because when we put it through here... Wait, process message. No, it should already be decrypted. Okay. Var 2 bytes. And then also, we need to remove the layer. We need to remove... No, payload still needs to be a byte array. And this should still be encrypted. And then that should just be process message. Decrypted message. And that should do like the normal logic for each one of these. Oh. Okay. Okay, let me walk through like the logic here again. Okay, let's see. So we get the initial payload, right? And we create a new RSA key. And that RSA key, we then get a random key for it, or a random ID for that message, right? And then after that, we encrypt the payload, right? And turn it into a byte array. And then we turn that back into another byte array, right? With this time with the wrap around it. And if it's encrypted message, okay. Okay, that makes sense. That makes sense. Okay, so if we receive something with a encrypted message as the type, right? Let me just make sure I got that right. Encrypted message as the type, right? Then we want to just save the message. Message identity. I don't know why, but I like it in this order a bit more. Payload. Message ID. Message payload, encrypted payload. Okay, and that's gonna save the message in the thing, alright? There we go. So that's gonna save the message, alright? And then if we have an encrypted key, instead what we're gonna do, right, is we're gonna decode the message, right? Message ID. And then payload. And payload key. Okay, that works. Right, so now we have encode, decode. Alright. We have saving the message. When we receive, we save. And then now, right? We just have a send key message, right? Send key, right? And that just has ID. Okay, we have to do a bit more designing here. We have to do a little bit more designing right here, alright? How do we wanna save the encrypted messages sent, right? I think just by their ID. Or do we do the recipient and then the ID, right? I think we just do the ID, right? Just to keep it a bit simple for ourselves. Unless... Nah, yeah. Let's just save only the ID, alright? Do I call it recipient? Target. This target. The order actually matters here, guys. The order surprisingly actually does matter here. Then we send Steam peer-to-peer dot send Oh no, we have the layout different for one of these. We have send message to user with that layout. We have process message and everything else with a different layout. I'm gonna have to fix that real quick. I'm gonna have to fix that real quick because now that I've seen it, it's gonna bug me. Yeah, I'm gonna have to replace all those real quick. Discard that. There we go. Okay, and then we're gonna have to replace Steam dot send message to user with Steam dot send There we go. Wait, let me pull this up real quick. Best practices. Introduction. Organization. Introduction. I think we're gonna follow the default thing. Style guide. Okay, so we do keep it in this state instead. Okay, makes sense, makes sense. Key. The type is gonna be encrypted key. The type is gonna be encrypted key with message payload message ID and then message ID and then key. Message ID and then key is just gonna be just the key. Okay, that's just whatever is in message sent, right? Sent by that ID. There we go. And we're gonna just send that over then. And then we just send that over, right? Yeah. I think that works. I think that works. Oh no. Oh, okay. Okay. Okay, send message to user, alright. Okay, just defaults reliable, channel 0. Okay, that's fine. That is perfectly fine. Okay. They should return a void. I don't want this to necessarily return anything. Key has no static type. This should be an int, right? It should be a crypto key. This should also be a packed byte array too, I believe, right? Yeah, I believe this should be a packed byte array. Okay, so then the key here. Oh. Okay, so if we're sending a key, right, as a packed byte array, I don't think it can store it as a packed byte array, right? Because this is an object, right? We're getting on a key, right? We have a crypto key, right? Right here, right? But okay, so we need to save this as a string, right? We need to save it to string, right? And we send it as that string, right? And then we have to turn it back into a crypto key. Okay, so we send it as that, right, as a string. And when we're decoding it, it should be a string, right? And then we load it as a string. Okay, there we go. Now we go to GitHub, right? Totally not searching up how to spell the word received right now. Do not worry about that, guys. There we go. There we go. And we're gonna push that. I am pretty happy with that code right there. I'm pretty happy with that code right there. Let me find someone to raid. Let me send you guys over to someone. Oh, this person has a cute setup. Wait, is it just me or is their audio like really, really low? Wait, let me compare it to Kiyu real quick. Let me compare their audio to Kiyu real quick, alright? Oh, I want to be able to, like, help them if they are having, you know, audio problems, because they do seem to be a new streamer, you know? So I'm like, hey, why not, right? Why not? Why not try helping people? Because I like helping people. Helping people, I think, is pretty dang pog, you know? I think helping people is pretty dang pog. But give me a second here. Q's I need to wait for Q's ad to be done. And there's like 10 seconds for that, right? There's like 10 seconds for that right now.
Are unmistakable. The icon was indeed responsible.
Here we go. Okay, yeah. I think their audio is a bit quiet.
I think I got like 300 the other day or something.
Yeah, their audio is a bit quiet. We'll hop over. We'll hop over and offer some help.
And I only used 50 that one night that we found Bella. So.
Okay, here we go.
Oh, hello, thank you. Thank you, that means a lot. Yes, I would love help. Yes. I would love that.
There we go. Okay. Okay. We're gonna offer to help this person with their audio mixing. Goodbye, everyone.